Okay, this is Mrs. Carreri, and I'm back. And today we're looking at chapter 1.4, section 1.4, and the title of it is Basic Math for Physics. Now, we've already done a math review, but there's a section in 1.4 that deals with significant figures and accuracy and precision. And I would not be I would not be doing this class justice if I did not at least address significant figures and accuracy and precision, because it's an important part of physics. We have to know how accurate we can measure something, how precise is the value, and so I'm going to go over that. Now, I know for a fact that you have had significant figures in the past, and I am going to quickly review this, and so hold on to your seats. But I also want you to know that throughout the course of the year, it's a goal, it's a really good goal to be very conscientious of significant figures. And but I in general don't take points off if you do not have exactly the right significant figures, but you will need to practice counting them, and we'll have a little quiz on it, but it is not a substantial part of this course, okay? But I need to go over it because I would not be a reputable physics teacher if I did not. Okay, so we are going to look at the standard that we're talking about here. I want you to be able to determine the correct number of significant figures of a value, okay? And I want you to be able to do certain math. I want you to be able to do multiplication, division, addition, subtraction, and keep track of sig figs, okay? So we're going to measure things like length, mass, time in our class, and we have to make sure we do those measurements accurately, and we need to express them correctly, okay? So when we make measurements, there is always a degree of uncertainty, okay? And we'll talk about what those are. So common things for uncertainty, common reasons for error in your lab results, okay? These are the most common. So a lot of times I ask you, what are your sources of error? And the favorite answer, students' favorite answer is human error, and I don't accept that as an answer. That's not good enough, okay? That means you didn't give it any thought. But here's some hints, okay? 3 common causes of error. What are they? Limitation in the measurement device. That is the biggest source of error, in my opinion, is your measurement device. Your device that you use to measure whatever it is you're measuring, whether it's time, whether it's length, whether it's mass. Your measurement device is what's causing the majority of your error, okay? Limitations in human perception. What does that mean? So your ability to actually see the car cross the finish line and hit the stop sign, or your ability to actually the time it takes for the ball to hit the ground and be able to coordinate your finger hitting the stopwatch at the exact time that the ball hit the ground. Those are human perceptions, okay? Limitations of the skill in the experimenter. Okay, that has to do with technique. Okay, so in AP Physics, for example, there's quite a few labs that are very hard, and you actually have to know how to use the equipment, and we have to, I might be able to get a little bit better results than some of the students, but I've also had a lot more practice, have I not? I used to work quite a bit of in the past in labs. So I have a lot more skill maybe in taking certain types of measurements. So your skill actually does make an impact. Your ability to use a protractor and figure out an angle. How many times have you done it? How many times have you tried to figure out how to be super accurate? So the skill of the person doing the experiment does make a difference. Okay, so you have heard in the past about accuracy and precision and what the difference of that is. So if you can see the picture of the dart, you can see that I've thrown darts, and I have a situation where I want the value to be in the circle, and if it's not in the circle, it's not accurate. Okay, so the top left is accurate. All of the darts are in the circle, so we consider that accurate. But notice also that the 3 darts in the top left are really essentially right on top of one another. So we have not only their accurate results, but they're very precise results. And what I mean by precise is the results are repeatable. So another way to think of precise is repeatable. So even though these right here may be accurate, it doesn't have the greatest precision, okay? Not quite as good as the one above it, all right? So those are the difference. So notice this. Here's something that's interesting. Sig figures, significant figures, are an indication of accuracy, okay? Because that's really the most important thing about sig figs. And you guys may or may not have been taught this. And so this is what I'm going to show you. You've been taught how to count sig figs, but do you really understand how to determine it based on a measurement device? That's actually even more important. So let's take a look at these two rulers. I want you to measure the length of this ruler. And this ruler has centimeters on it, okay? And so I can tell that it has 1 centimeter, 2 centimeter, 3 centimeter, and so forth. And so I'm looking at this leaf, and I know that it is greater than 3 centimeters, right? And I know that it's less than 4 centimeters. It looks like it's about halfway. So I'm going to say 3.5. Well, this value right here was an estimate. And you had to estimate that based on the fact that there were no, your measurement device did not have more precise tick marks, okay? That's an estimate. And this value has 2 significant figures, okay? 3.5, and that was determined by that ruler. Now let's pick another ruler. This is in centimeters, and this is 3 centimeters, and every single tick mark between 3 and 4 is 0.1 centimeters, because I can go 3.1, 3.2, and all the way up to 0.9, and then I hit 4, and I'm going to draw a line, and I find, and I'm trying to make it so that it's similar to the book, that I know it's above 3.5, but it's less than 3.6, so I'm going to estimate it's 3.52 centimeters. And you estimated this digit. And now this device, which is more accurate than the previous device, has the ability to have 3 sig figs. Okay, so your device is what determines the number. Your measurement device is what really determines the number of significant figures. All right, so here's a hard one. Let's look at this one. Why don't you pause your video and try this one? Okay, so I'm assuming you're back. This line is 40. And this is 39. It's kind of hard to see that. Here's 41 down here. So this is 40.5. So each one of these lines, so this is 40.1, 40.2, 40.3, 40.4, 40.5, okay? Each one of those lines is 0.1, and this is in milliliters, we'll assume. All right, so it's in mils. Actually, they told us that right here. And we want to know what the value, the liquid, so it's between 40 and 41, but it's greater than 40.0 and less than 40.1. So it's in between the 0.0 and 0.01. So we could say that I'll estimate that to be about 40.05. So I have assumed that it was halfway in between that. So that digit is my estimate. I estimated that. Now, it doesn't make sense. Would it make sense to say 5.5? I mean, that doesn't make any sense whatsoever. You do not have the ability to make that estimate at all. That's a guess. It's not an estimate is kind of sort of a guess, but it's an educated guess. Okay, so this is not an acceptable measurement using that device. Okay, and so in this situation, we indeed have 4 significant figures, and that barrette is what determined how many sig figs that measurement had. Okay, let's take a couple look at some additional ones here. So maybe you're starting to see a pattern. Okay, so I have a pistachio. I have it on this device here, and I can see that I am at 0, and this is at 10, and every single one of those tick marks is 1 gram. And so here is the tick marks right here. You can see I have it listed at 1 gram. Okay, now I know it's between 1 and 2 grams, and I estimate it to be 1.2. So I have 1.2, and 0.2 is my estimate, the digit and 2. And so what you're starting to see is that if you know the tick marks, if you know what the value of the tick mark is, it's the next digit to the right is the last significant figure of your measurement tool. Okay, so let's take a look at this one. Same exact pistachio. is now on a different device, and it has, if I were to draw here, this is my, let's see if I can, you can actually see it. Oh, probably not gonna be able to see this. There's my 1 gram, this is my 2 gram, and then I have lines between 1 and 2, and those are 1.1, 1.2, 1. And now I have marks where every 0.1 gram. And so I can estimate between 0.1 and 0.2, and I've indicated that the reading is now assumed to be 1.27, and so I had that 1 digit to the right of what the measurement tool is, and that's my estimate. And so I have 3 sig figs, and so it's the same pistachio, but now I have a more accurate data point. Okay, here's another. These pirouettes always give students problems. So this one actually is going in the opposite direction. So I have 4 going up to 5, which is a standard burette. The other one is a little bit tricky. And so I have 4.1, 2, 3, 4, 5. It's in between 4.5 and 4.6. I would assume that would be 4.5, we'll say 7 mils. And so this is a 3 significant figure. And once again, my measurement tool is what's determined it. So